Hey y'all. Today we're going to take a look at adding and subtracting with our radicals. So we're still going to use some of our skills from yesterday as far as doing factor trees and looking at the index. So the index tells you what groups you're looking for. Complete groups of the index go on the outside of your square root. Everything else goes on the inside. So I'm actually going to start with this star problem here. So I'm actually going to do like a little side note before we jump into our three problems that are up there. So we're going to simplify the 5 square roots of 2 plus 7 square roots of 3 minus 8 square roots of 3 plus 9 square roots of 2. So we're going to simplify this problem. You can only combine terms that are alike. So think of like terms. So as you look up here, hopefully maybe you're leaning towards the 5 and the square root of 2 being combined with the 9 and the square root of 2. You would be correct. You only can combine terms that have the same number underneath the radical. So square root of 2, square root of 2, and they both have the same index, which is 2. So those are like terms. So you just add the coefficients, 5 plus 9. That would give me 14 square root 2. So that's the first part of the problem. Now, other things that go together in this problem, these are both square roots of 3, so they are also like terms, so to speak, so I can put those together. So 7 square roots of 3 minus 8 square roots of 3. 7 minus 8 is negative 1 square root of 3. So that is my final answer. So you only can add or subtract radicals that have the same number underneath the square root. So we put the square roots of 2's together and we put the square roots of 3's together. If I can factor 2, I would, but I can't. If I can factor 3, I would, but I can't because those are prime numbers. So I can't break those down anymore. So this would be my final answer. So I got 3 problems up here that we're going to have to do. They're going to be a little bit more involved because as you can tell, none of those start with like terms. 8 and 18 are not alike. 375 and 24 are not alike. And 32 and 48 are not alike. So we're going to use our factor trees and skills that we've been building up to break these down and to combine them into like terms. All right, so I'm going to get rid of this problem. This was just like a basic problem just to kind of get your mind steered towards where we're going. So think of like terms. They have to have the same number underneath the square root. Okay, so let's jump into this first problem here. So the square root of 8 plus the square root of 18. These are not alike to start with. However, we can use our factoring skills and break these down. So we're going to break down 8 and break down 18. So here we go. 8 is 4 times 2. 2 times 2. Pairs go on the outside. Everything else goes on the inside. I'm going to do the same thing with 18. 18 is 9 times 2. This is 3 times 3. Pairs go on the outside. Everything else goes on the inside. So we did our thing that we've been factoring for a while. I did a little factor tree. I got a plus sign in the middle. So my plus sign is going to come straight down. Okay. Now I have like terms. They both have the same index of 2, and they both have the same number underneath the square root. So now I have like terms. Now all I have to do is add a number in front because it's an addition problem. So my final answer is 5 times the square root of 2. Ta-da! So final answer is 5 times the square root of 2. So that's all there is to it. So if it doesn't start as like terms, we're probably going to have to do some sort of factor tree and break it down so that it is like terms. All right, let's move on to B. The cube root, so that's a 3. The cube root of 375 minus 2 times the cube root of 24. So both of these have a cube root of the number 3, just in case you can't see that up there. So we're going to break down 375. Let's do 25 times 15. 25 times 15. Let's break down 25. It's 5 times 5. 15 is 3 times 5. My index is 3, so take that time, be careful, go back and make sure you check your index. My index this time is 3, so I'm looking for 3 of the same numbers. Complete groups go on the outside of your square root. Leftovers go on the inside. So that's the first part of the problem. I had 3 5s that went on the outside, and then leftover prime number is 3 that goes on the inside. Okay, we're going to do the same thing here. 24 has a lot of different things. Let's do 6 times 4. I can do 2 times 3. I can do 2 times 2. My index is 3. Check your index. Index 3. I'm looking for 3 of the same number. So I got 3 2s. Okay, that's going to go on the outside. Leftover prime number, which is the number 3, goes on the inside. And I got to be careful. I already had a 2 that was in the problem that was in front of the whole thing. So this 2 is going to come straight down. So I'm going to write this for the time being. I'm going to write it as, put a minus sign here, and then 2 times this here. Let me write this all in the same row so that we don't get confused. 2 like this. All right. So this part of the problem, 2 times the cube root of 3. This part of the problem came from a group of 2, and then you bring your index down and leftover prime number. This 2 I brought straight down because it was already in the problem when I started. So this 2 came straight down. All right, I'm going to bring this side down because I can't do anything with it just yet. I'm going to bring it straight down. 2 times 2, that's going to be 4. Now we are in business, and they are like terms. We're in business. They both have the same number underneath the square root, and they both have the same index on the outside, so they are like terms. So the only thing left for us to do is do 5 minus 4. So my final answer is 1 times the cube root of 3. And you probably would not see this 1 there. I'm just writing it so that you know that we did 5 minus 4. But more times than not, you would not see that 1 there. Just writing it for studying purposes. And last but not least, we're going to break down the 4th root of 32 plus the 4th root of 48. So we're going to go through and we're going to do a factor trees. Hopefully your factor trees are coming much faster. Sometimes something, boom, boom, break it all the way down to prime numbers. So here we go. 32. Let's do 8 times 4. This is 4 times 2. I can do 2 times 2 and 2 and 2. So my index this time is 4. My index is 4. Make sure you check your index as you go through and pick groups together. So I'm looking for 4 of the same number. 1, 2, 3, 4. So let's put these together. Complete groups of your index go on the outside. So 1, 2, 3, 4. Leftover prime numbers go on the inside. So the 4th root of 32 simplifies to 4 times the 4th root of the square root of 2. Okay, I'm going to do the same thing with 48. Lots of things giving me 48. Let's do 8 and 6. So 8 times 6. I can do 4 times 2. I can do 2 times 2. I can do 3 times 2. So I did a factor tree. We're looking for 4 of the same number. So 1, 2, 3, 4. So I can put these together. Okay. Complete groups of my index go on the outside. So I have a complete group of 2. I got 4 2s. Leftover prime number goes on the inside, which is 3. And I got a plus sign in the problem, so I'm going to bring my plus sign down. Now, if you look at this problem, so you might think that, well, we must have did something wrong because the other ones both turned out to be the square root of 2. This one both turned out to be the cube root of 3. This one is the 4th root of 2, and this one is the 4th root of 3. That's okay. So for this particular problem, they didn't simplify to be the same thing, so I cannot add these together. This is the 4th root of 2. This is the 4th root of 3. Yes, we have the same index, but no, we have different numbers underneath the radical. So this is our final answer. Do not do 4 plus 2. Do not do 4 plus 2 because these are not like terms. 1 is a 2 and 1 is a 3, so I cannot put those together. They are not like terms. So this is all there is to it. Adding and subtracting our radicals. You're going to want to do your factor trees like we've been working on. Check your index. Complete groups go on the outside. Everything else goes on the inside. If you have like terms, add or subtract the coefficients. And if not, you leave it just like that. And there's nothing wrong with that. So don't think you're wrong.